Of course, often we hear questions: how to create, maintain, and even upgrade large-scale environments. This is very common, and this is something that we wish to help you figure out. Our next speaker is dealing with just such environments, and she's responsible for doing just that: maintaining, constructing, upgrading large-scale environments for cloud-native environments. So let's welcome the technical manager for China Mobile from China, Wang Manxue.
Hello everyone, my name is Wang Manxue. I'm from China. It's my great honor to speak at the Zabbix Summit Online 2020 and to share my monitoring experience of the world's largest call center. My presentation today will mainly cover four small topics: the background, the way out, the transition, and the precipitation. Now, let's start with a short introduction of the background. China Mobile is the largest telecom operator in China. The company I worked for is China Mobile Online Service. It is a professional subsidiary of China Mobile. We are responsible for the construction and operation of China Mobile's call center. Our company is a traditional company, but we have a huge amount of users, 910 million. Such a large number of users means that our online system must be a distributed and high concurrently system. Now, as you see, we have a large IT scales with IDC all over 31 provinces and tens of thousands of physical equipment. The online system is also changing rapidly. Many new technologies have been adopted, such as microservice, containers. The average daily online release is over 120 times. That is a very enormous number in traditional operators. So it is very complicated and bring many challenges to our OPS. Facing so many difficulties, how can we find the way out? For traditional operator, we don't have the many high-grade talents as internal giants, such as Google, Alibaba, and so on. And we don't understand how the Linux system kernel is developed. It is almost impossible for us to develop a monitoring system with high concurrently and high compatibility in a short time. So what shall we do? We embrace the open source software. After doing a lot of technical research, we chose to stand on the shoulders of the giant Zabbix. Using Zabbix's ability, we built 37 monitoring templates and made the system online rapidly in 1 month. Within 3 months, we cover 100% of the company's network equipment, physical servers, cloud infrastructures, database, and middleware monitoring. 3 months, this speed is unbelievable. Zabbix is very stable and has been running since 2017 without major failures. Then we have made a nice combination of Zabbix and Grandfather. Using its nice dashboard, we output a lot of monitoring reports for everyone. So, how we constructed the system in order to promote and implement the monitoring solution quicker and easier, we adopted the construction mode of centralized building, unified management, and standardized accessibility for all our branches. That means the headquarters is responsible for establishing monitoring capabilities, standardizing the configuration of proxy, and making the collection, analysis, display, and notification of all monitoring data. We use the template, we deployed some, we modified some, in total 37 capabilities. and the branch only need to continually maintain the proxy. Now, let me show you something. These are the middleware monitored by Zabbix. And these are the network devices monitored by Zabbix. These are the dashboard made with Grafana. Within half a year, our monitoring system has 2 million monitoring items and 84 proxy, and generate 300,000 alerts per every day. In order to make better use of Zabbix performance, we have done some optimized work. For example, we have disabled housekeeper, enabled database table partitioning, forbid agent connecting server directly, and we adjust and optimize some configuration parameters in Zabbix server, and so on. In 2020, we have also made a dual center high availability solution for Zabbix. At the beginning, we just built a Zabbix server in data center A. When Zabbix server fail occurs inside data center A, we use Keep Alive to achieve high availability handoff. Well, if center A fail occurs in large scales due to the network or power, we will lose the whole monitoring system, which is completely unacceptable in our company. So, we deployed another set of Zabbix server in data center B, and the configuration data is synchronized from center A to center B in real time. DNS domain name resolve can help us switch the monitoring from center A to the standby node of center B within 10 minutes. Generating the real-time data after the switch, only the historical data is lost. For monitoring service, there is no downtime. Now, share a relevant experience with you. It is necessary to formulate monitoring specifications before adding any monitoring. Standardize the name of template, groups, items, triggers, actions, and more according to your own situation. Otherwise, the larger the monitoring scale is, the more troublesome and complicated it will be when troubleshooting. In the third part, we still faced the problem during the transition period. Once our service was done and we didn't get any notification while we are collecting 2 million items. From then, I realized what we have monitoring only just the path and ICE layer and not the SaaS level. So, the service health monitoring and user experience monitoring should be fully paid attention. Then we made 2 improvements. First, adding application performance monitoring, APM. The metrics, logs, trace, entity relationships, user experiments, and user behavior were fully connected by APM, improving the observability of the system, providing the ability to find the internal problem of the complex system. Second, we hope to find some common monitoring patterns, which indicators can provide a broad range of information about my service. So we studied the book called Google's SRE and used its 5 golden signals. Each service monitoring must have the indicators of these 5 dimensions as basis, like rate, error, latency, saturation, and utilization. It could be more, but cannot be less. Based on all those experiments, we sorted out our whole set monitoring solution for cloud-native system. From top to bottom are users' experience, business health, entity relationship, application, container, system, cloud platform, and the environment monitoring. Using those metrics collected, we successfully increased the observability of our complex system and the ability to understand and solve any issues that arose. Finally, let's look at our current all-in-one monitoring platform. Many different open source monitoring systems are used as a bottom layer to collect monitoring data of various dimensions, like log platform, Prometheus, Zabbix, APM, and some professional management system. Then we process those data in real time or offline or even handle it intelligently. Thereby, we can discover all the components and dependency of entire technology stack end-to-end. In the way, we can have end-to-end monitoring and provide a real-time topology. No system blind spots anymore. Problem can be solved rapidly and eventually. Our customer will have great experience. Now, let's come to the last part, automation and digital analytics. First, come to the automation. As we mentioned earlier, the company's monitoring platform adopts the mode of centralized construction and centralized operation. That means all monitoring requirements are supported by one team. So, how to simplify the complex monitoring operation? How to deal with the rapid extend scale? We have made a set of monitoring automation tools based on Zabbix API. It can add, delete, modify, and search the monitoring data on the page in path and self-service. At present, this tool has been able to handle 85% of the monitoring requirements automatically, greatly reducing our manpower burden, and just 2 engineers can fully operate the monitoring platform. Then comes to the digital analytics. Extract Zabbix Prometheus, alerting platform, log platform, CMDB, and the other data to load on the big data analysis platform and to analyze the data in multi-dimensional. First of all, we combine the monitoring data with business KPI indicators to obtain real-time business health analysis, so as to make IT and business cooperate more efficient. Secondly, we have just seen that data path players on the whole monitoring platform. What is the use of the data extracted from a lot of self-service monitoring tools? Well, it can be used for report analysis, like analyze alerting numbers according to the business dimensions and optimize the alerting cooperatively, providing no real-time business health weekly report analysis at City High. In addition, it can also enrich a lot of indicators, such as break the barrier of data storage and add metrics like month-on-month, year-on-year. Finally, what I recommend to you is application expansion, which is used for rapid full location, root cause analysis, full self-healing, and capacity management. Now, After the monitoring platform has been launched for 3 years, our monitoring platform has accumulated 26 million monitoring items, processed 60 billion logs, and generated 1.98 million alerts every day. These are numbers that make me feel very fulfilling. In the future, we hope to further introduce intelligent capability into the monitoring platform. We will conduct in-depth research on intelligent anomaly detection, intelligent root cause analysis, intelligent fall prediction, and so on. So that's all. Thank you for your listening.
Wow, that was quite an impressive environment.